Okay, hello everyone. We're going to continue with PowerPoint number 3, the second part, part B, which is about basic concepts of probability. Next week or next time, we're not going to meet next week. There will be no session next week. So that I give you time so you can catch up with your quizzes and SPSS assignments. So we probably have another session, asynchronous session in 2 weeks. For those of you who emailed me your SPSS, thank you. You did a great job. And for those of you who haven't done it, please do so as soon as possible because you don't want these assignment accumulate. It just adds up and then you stay behind. So yeah, please let me know if you have any question, any concern, and keep up the good work. So without any further delay, let's continue with the second part of this PowerPoint. Keep in mind you have access to all these PowerPoints and read the syllabus if you haven't. It has a lot of details in there about every session and your assignments. Okay, so probability. Let's see. What is probability? The number of times an event occurs in an infinite series of trials. We already mentioned that last time. And the formula for probability is F over N times 100. P stands for probability. And we report the probability in percentage. The formula again gives you uh, a proportion, but multiplied by 100, that becomes probability percentage. So number of F is frequency or number of times an event occurs, and N is total number of trials. So if you have a coin, you flip it, the frequency of getting head or tail for that matter is 1. There's only one tail, one head. And the total number of trials are total number of possibilities are 2. So 1 over 2 is 0.5 times 100 is 50%. So chances to getting head or tail is 50%, 1 out of 2. For probability to be accurate, it is necessary to use random sampling. And it's on, you should know about random sampling. If you don't, and again, random sampling has 2 requirements. Read them in your PowerPoint. Each individual in the population must have an equal chance of being selected. So it's like put all the name in a hat and just draw one, or use computer to randomly select. If there is more than one individual or group of individuals is to be selected in the sample, there must be constant probability for each and every selection. So what does that mean? It means that let's say here we got 15 marbles in a jar, 5 red, 5 yellow, 5 greens. So the probability, it's like say probability of pulling one red marble is 5 over 15. The frequency of red is 5 and total number of marbles or trials are 15. 5 over 15, 1 over 3 times 100. But the thing is, if I select 1, right, it doesn't mean that for the next person who wanted to uh, select another, the probability of, let's say, green one, it's the same. That means that I put that marble that I picked back in there. It goes back in there, so it's going to stay the same. Same as, let's say, research. In research, let's say if your university has 2,000 students, if I take a sample of 500 students and do research with them, there's still 2,000 students that are there. That means I don't put those students in my pockets. They there. So you can take unlimited sample from a population. That's the meaning of what it says. Random sampling requires these three. The probability cannot change during a series of selections. That means if semester, let's say this semester we have 2,000 students, that's it, that's 2,000. There must be sampling with replacement. That's what I just described. Put it back in the jar. If I take a sample of students, and then it goes back into the population for the next person and the next person. Every individual has an equal chance of being selected. So that's the requirement for random sampling. As you can see here, we have 2 dice. And if you look at one of them, the probability of getting number 3 with one throw will be 1 over 6. As a matter of fact, any number. There's 1, 2, 3, 4, 5, 6. So what's the chances to get 2 or 3 or 5? It's 1 over 6. 1 is the frequency of that number, and 6 is the total number. So, but if you have 2 dice and you throw both of them, what's the chances of getting 2, 3? That multiplies 1 over 6 times 1 over 6 should be 1 over 36, then will be over 100. So this is really a basic structure for slot machine. Slot machine work the same, except they have more numbers and fruits and bars and all that stuff. This is the old one. As you can see, it's just like a dice. You're throwing 3 dice. And if they all be 7, 7, if there's only 6 of them, there's 1 over 6, 1 over 6, 1 over 6 times 1 over 6 times over 1 over 6. Or if whatever it is, that's if it's a number. Or if it's a fruit or bar or whatever it is, it's the same. And the more stuff you have there, the more chances that you would not gonna have those 3 numbers lined up. And this is the old mechanical ones. Nowadays, they have more sophisticated with many different rows and many different fruits and bars and numbers. And that means your probability of winning becoming less and less the more they put in there. Same as deck a card with 52 cards in it. There's some fun information about probability. So next time when you decided to get your Powerball, your chances are 1 in 292 million to win. But the strangest thing is that someone always wins. Lottery in Florida is 1 in 23 million because there's less numbers. But the chances of hit by lightning is 1 over 15,000. That means by far there's a good chance that we hit by lightning than win a lottery. And then there are others, lottery we have in Florida, like Fantasy 5. And then victim of crime in the US is 1 in 8,000. Chances of becoming a victim in Florida is 1 in 205. In Miami will be 1 in 85. And these are facts. Chances of becoming a victim in Florida is 1 in 31. In Miami is 1 in 19. In general. So this is what we covered last time. We talked about Z-score, and we said there are two different types of Z-scores. One for the single score, this is the one we talked about. And there's another one which is for sample. It's the same, it'll be the same, except on top, the X is a score for one person, but for the sample will be M, which is sample mean minus population mean divided by standard error of the mean. So we talk about that. What is the standard error of the mean? But for now, we're not going to go for the one that deals with research. We're still using this same formula. And at the bottom, we said that the formula for the probability is P equal F over N times 100. And F is the frequency, and N is total number of trials. And then also on the right side of the screen, you see that those different measurement, one is percentage, and the top one is proportion. Percentage is from 0 to 100, proportion from 0 to 1. And we talked about how to convert one to another. Also, you need to have a book, because at the end of each book, there are critical values. Here you're looking at the critical value for the Z-score. And on page 744, your text. And the way it works is you'll see 5 columns on the left side of the screen and 5 on the right. So the first column is called Z-score. These are critical values for the Z-score. Once you calculate the Z, that would be calculated value for Z. But these are critical value for the Z. Also, you see that, okay, so I label that as A. Then you see mean to Z. Mean to Z is the distance for probability of a score being from the Z-score. If you look at that distribution on top, you see that in the middle, that's the mean. And then that red line, that black line in the middle is mean. The red line is the Z. So the area between the Z and the mean, or mean to Z, we call it D, and I wrote D in there. And then the next one is called larger portion, and the other one is called smaller portion. We call the larger portion body and the smaller portion tail, or C. Body B and tail C. When you see that red line right there on that distribution, if I draw that, I can find out exactly what z-score is right there. And it depends, or in this case, we're dealing with probability. I can tell that what's the probability of getting someone score, let's say right there, z of, let's say, 1.5. If their score is greater, if it says greater, means to the right, or less than z of 1.5. Less than means to the left, that white plain area, which is called body. But the shaded orange to the right, that's tail, that small one. If the line is in the middle, even Steven, then there's no body or tail. You just right in the middle, 50% chance for each in terms of probability. But if it deviates from to the left or right, then you draw a line like that red one, and then depends on which area you're interested in to know the probability. And based on that, you look at these numbers, and whatever the number is, you multiply it by 100. So if it's 0.5 in the middle, it's 50%. But if it's like, let's say if I'm interested in the orange area, and I believe Z is, let's say, if I go down to the next page, let's say right there, the red line is 1.15. Then if I look for the body, large area, it says 0.87 or 87% because it's large area. And the tail will be 0.12, 51%. Okay, so we're going to do some exercise. That's what we're going to do. It's all about, these exercises require a spatial ability, being able to look under these distribution, normal distribution, and know what are we looking for. Your first task is to find out, are we looking for the tail? First you draw the line. If the red line was on the left, then again, it doesn't matter, left, right side of the mean, then you need to know, are we looking for the number greater, means to the right, or less, to the left. Based on that, you need to determine the size of the distribution. If it's somehow smaller, then you're looking for tail. If it's greater, body. So let's just move. So that's what they are right here. As you can see, the numbers, let's say on the first column, start with the last one, that Y, that we don't have any use for it now for this semester. So those 4 columns, the first 4 columns, as you can see, column Z, the first one, it goes, start from Z of 0 and goes to 0.35, and then goes to the right side, again Z, 0.36, 0.37, and then goes to 0.71, and then continues 0.72, and then go to the right side and beyond. Again, you gotta have book to have this, or print this pages because you can't do this next quiz without these critical values. Also, for your convenience, this is a z-score calculator. You want to use it, you're welcome to use it. All right, so let's do some of these activities. It's all about the area under the curve. It says, what proportion of the normal distribution correspond to z-score value greater than 1? So first step, keep in mind, all these activities have 4 steps. Step 1, draw your distribution. Like I did right there, normal distribution. Step 2, so you draw your z distribution with a mean of 0, a standard deviation of 1, 1, 2 to the right, -1, -2, 2, 2. Then it's a pay attention to the question, see what is it asking you. It says, also if you notice, I underlined the word probability. Keep in mind the probability means percentage. Your answer should be in percentage, not proportion. The value that you're going to look in the back of the book, those critical values are in proportion. If it says probability, you need to, once you find it, multiply it by 100. But if it says what proportion, then you don't have to. So it's just like a brain teaser. And, you know, that's what the statistic is. It's really, I'd say at least 60, 70% of statistic is just concentration. So what proportion, so pay attention, the proportion of the normal distribution correspond to z-score value greater than 1. And this is how you write it. P, probability of z-score greater than 1. So you got your distribution, mean, okay, normal distribution, and where is right there, z is 1, not -1, but 1, which is +1. So you draw that black line where the 1 is, but then it says greater than 1. I underlined that for you, so you pay attention to that. Greater means to the right, greater than 1. That means more than 1, 1.5, 2, 3, 4. So we are interested in the area to the right. We wanted to know the probability. What percentage is that area that are shaded in black? How do we do it? Once again, now we need to determine what are we looking for. Are we looking for the area between mean and the z, which is this area, or the large area, the body, that means this area to the left? That is if it says less than 1, but it says greater than 1. As I mentioned earlier, we're looking for tail because it says greater than 1. And that area, let me draw this area right there. This is what we're interested in. That is tail, which is C. Okay, so well, we need what? We need the tail when the Z is 1. We go back to our critical value, and when the Z is 1, Z is first column, and right there in the first column, the red line, Z is 1. What would be the tail? Right there, again, red line, it says 0.1587. And that's in proportion. Since the question is saying probability, multiply that by 100 and you get 15.87%. And I have the answers for you for your convenience, so you can do these practices before you take the quiz. So there it is. If it's proportion, then the answer is 0.1587. You look them up. You don't do any really calculation. You have to look them up. Proportion. But if it's probability, is 15.87. Next one, for normal distribution, what's the probability again of selecting z-score less than 1.5? So again, you should be able to do this. Now, instead of 1 point, z is 1. So the 1.5 is a little further to the right, but it says less than. That means we're interested to the left, and it's huge. It's the body. So z is 1.5. What is the body? You go back. Z is 1.5. Z is 1.5, and look for the value for the body, which is the third, 0.9332, I believe. Yeah. Make it larger. There you can see. So again, if z is 1.5, we want the body larger, or body 1.5, 0.9332. That is again to the left, the larger area. And the next one, the body, the tail will be less. It will be 0.000. But they want the body. So this one is greater. Okay, this is greater than 1.5, so they want the tail. So 0.0098. And then it's a probability, so multiply it by 100. Let's go back again to 1.5. Make it full size. Right there. Again, if it's body that you're interested, is 0.9332. If it's tail, if it's okay to the right, then it's 0.0668. That's proportion. And you multiply that by 100, would be 6.68. This is how you look for them. So All right, if it says less than 9.93, that's the body, and if it's the tail, then it's the small one, 6.68. All right, so you can do these or practice. I'm not going to do all of them. Get you some idea. Um, what proportion of the normal distribution is contained in the tail beyond the z of z zero point 0.5? So beyond means far and beyond to the right. Z is positive. That means they want the right area. Zero point 0.5, you got 1. This is, again, first thing, you draw your distribution, Z distribution, with a mean of 0, standard deviation of 1. And then this says 0.5 is positive, so the red line on the right, it says beyond. That means we need the area on the right, which is tail. And then again, the 4 says if z is negative 0.5, so the red line to the left side of mean. And then again, same thing, beyond means as far as you can go in that area to the left. So make a long story short, as you can see also visually, it's the same distance. So either way, you go look for the critical value for the z when for the tail when the z is 0.5. Keep in mind those critical values that are given, they're all in positive. Since this normal distribution is symmetrical, all right, it's like an apple cut in half. The right side and left are mirror image. So if it says 0.5 to the right tail or negative 0.5 to the left tail, it's the same distance as I illustrated here for you. And then you go there, and so we're interested in z is 0.5, and what would be the tail? Let's go look it up, and you have an answer for both of them. Slideshow. Z is 0.5. Z is 0.5, so the first column, Z is on the right side, right there when the blue line is, Z is 0.5, and we're interested in tail, which goes to second, third, fourth column, and is 0.3085. The numbers are given in, again, in positive. So if it's on the left side, will it be the same? These are proportion 0.3050. These are proportion, and you want to convert them to probability or percentage, multiplied by 100, so will be 30.50%. You can see right there. If it's proportion 0.30, oh, right here. Right here. Either one is 0.30, 0.50. To the right or to the left. This is, all right, so this was pretty much the same right there. And this one too. Again, you can practice with them. If you have any question, let me know. 0.30, 0.85. What proportion of a normal distribution located between the z of 1, 150, and this one between z? So again, these are a little different. They want the area. Again, you got to use your spatial ability. They're both the same. Uh, if you look at the bottom one, which I already illustrated, it says z of positive 1.5 at the bottom. So the middle, that dark line, that's the mean. If z is 1.5 to the right, we draw a line, a hypothetical line, and on the left side, another one, hypothetical line. But they wanted to know that right there, that area in the middle, what proportion of a normal distribution, or what's the probability right there in that area? It's just proportion. That means you don't have to multiply it by 100. So, but it doesn't matter, proportion or probability. Just pay attention when in multiple choice, you know, if it says 100, if it says probability, then the answer should be percentage. If it says proportion, the answer shouldn't be. So what do you do? Again, since they are equal distances, you need to know what's the area between mean to z. Mean right there is z. Z is 1.15. Once you got that area, multiply it by 2, because the left side is the same, and that gives you the number. So let's say mean to z for 1.15, and the top one is same, two different numbers. You add them up. 1.15 1 point right there. I underline it on the right side of the screen. Z is 1.15, so mean to z right there, I underline it, is 0.3749. That's proportion. If it says what's the probability, right there in that area will be 37.49%. So the answer for that one is 0.3749. Right there. So you add them up. 0.3749 times 2 will be 0.7498. So you add up the right side portion and the left side of mean, right? And we found that area 0.37 is on the right side. So the left is same. So you add up those two. On the top one, same thing. This is the area between 1 and 1.5. You draw the distribution, and you have 1, and then you have 1.5. So right in the middle of those two. And those are the answers, you know, that you can correct yourself. Once you get, you feel comfortable with these, then you can take your next quiz. And these are a little different. Again, now they asking for the z-score. They're asking for the z-score. So it says, what's the z-score? Well, what z-score separates the top 10% from the remainder of the distribution? So again, you need to have your distribution. That's your z, as I illustrated the top one, with the mean of 0, standard deviation of 1, 2. And then, okay, you know that the total area under the curve is 100%. So you draw a hypothetical line, like I did, And it says, what z-score separates the top 10% from the remainder of distribution from the bottom? They want that right there, the tail, the top 10%, right there. We have that. They gave us that, but they want to know what z-score should be exactly. Is this z1, 1.1, 1.5? Is it 2? What would be the exact z here, z-score? Again, we have the value for the tail, which is in probability 10%. We need to convert it to proportion, because when we go look at the proportion values, the values in your book, those critical values are given in proportion. So we need to look for, make a long story short, we need to look for a tail of 0.10. That's when you divide 10% by 100 is 0.10. So we're saying basically if the tail is 0.10, cross over and tell us what's the z value. So tail, a small proportion is 0.10. Okay, it's next. Tail, look at the fourth column, should be point right there, should be 0.10, the closest number you can get to that. The tail should be 0.1 on the right side. You can see it right there. At the far edge, I have a blue line, and then the third column, which is small portion, is 0.100. That's the closest you can get to 0.10. Okay, so we have that. That's 10% in probability. 0.10 is 10%. We converted the 10% divided by 100, so it's 0.1. But they want the z, so you cross over to first column. Again, I underline it in red. Z is 1.28. So if that percentage is 0.10 or 10%, if the tail is, what would be the z? 1.28. That's the answer. Okay, so that would be the answer for that. And this, for this, 10%, this one. right there. So that's the answer for that. And for this one, they say middle 60%. Middle 60%, again, that means you look in middle, that's mean. So that means 30% to the right, 30% to the left. And same token, you have the air, it says, on the right side, the value, again, is the mirror image onto the left. If you find out what that area is the mean to z. Mean to z is 30%. Divided by 100 is 0.30. So you go look in that column, which it says mean to z, and look for 0.30. 0.30, that's proportion of 30%. And cross over to the z. And the value that you get, it should be, you say 42% or 0.42. But you add them up because they want the whole middle percent. So that will come out with 84%. As you can see, I have it here. So again, you got to keep practicing with these, and then let me know if you have any question. Kind of brain teaser. In terms of SPSS, this is how you do your SPSS, step by steps. So you go to open your SPSS, variable view, you type in, let's say gender. This is like probability. You got a sample of males and females, and whatever, you got 30 males, 50 females. What's the probability of selecting a female or male? So your variable is gender. You name your variable is gender, and then you go right there when it says value. If you click on that, it opens up, and then you give, like that little window, you give, let's say, let me make it larger. Right there where it says values, you give 1, click 1, and then it says value 1, and then label it as female, and then add, click on add, then type 2 and label it as male, and then add. They both were going to be there. Then click OK. So this way you quantify your variables, because SPSS doesn't understand words. You have to quantify them. Like you say, hey, you see 1 means male or female in this case. 2 means female. And then you enter your data, like 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, right? It doesn't matter. You can put 10,000 number there. SPSS now knows that 1 means female, 2 means male. And then if you go to analyze, all right, and then non-parametric test, click on one sample, and then click on this one, the first button. It says click on scan data, and then right there, click on objective and run, and make sure that one is click, that one, the first top one, automatically. Then you will have something like this. All right, if you double click on it, it opens up to something like this. And then again, we'll talk more about this next time. Like I said, you're not gonna have any extra assignment for the next week. Or yeah, um, just do all your quizzes, catch up with all your SPSS, email your SPSS to me. I think that would be best. Then you would know right away. I would let you know, respond that I got it. And if there's anything, I will let you know immediately. But we will talk about next time about that hypothesis testing. What is the meaning of that? But what you see on the right, again, you see color coded like female in blue, male in green. It tells you the probability of each gender and the total number and all these details. SPSS always give you more than what you ask for. So that's pretty much it for this session. And then next time, again, we will go over the hypothesis testing and we explain that. So please read the sample review question for the probability, do your SPSS assignment, take your quiz, and read the PowerPoint number 4, which is about sampling distribution and hypothesis testing for the next session. That is about that sample z-scores, a different type of z-score we use for research. It's slightly different than the one we used last two sessions, because the one we used for last two sessions were for single score, 1%. But we're gonna, again, this one is gonna be slightly different. We're gonna use sample mean. And once you master it, then we'll, again, the following session after that will be hypothesis testing. That's for the remainder of the semester, and even for your advanced stats. That's what we're going to do. We're going to follow this hypothesis testing. The only difference will be each time we test different, we use different test statistics in our hypothesis testing. Like once we finish with the z-scores, then we go for t-test. And there are 3 different types of t-tests: for single sample, for repeated measure, and for independent samples. 3 different sessions, each take a session. And then we move to ANOVA and beyond, and then we take it further in advanced statistics. Other than that, this is it. And please let me know if you have any question, concern. You have a great week. And I will see you next time.